This is not my main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco places got me slowly taking over. I can't wait to show you that I'm gonna take it over. Leetcode, beast mode, 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 Leetcode, beast mode. This is not a main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco places got me slowly taking over. I can't wait to show you that I'm gonna take it over. Leetcode, beast mode, 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 Leetcode, beast mode.
Yo, chat. What's up? Long time no see. Let everyone roll in. I haven't streamed in literally a month and 5 days. Is the longest I've never went streaming for. I haven't even touched... Yo, Mertizzi. I haven't even touched Leetcode in a month, so I'm probably rusty as hell. But we're gonna see how we perform. We got some more coding interviews coming on today. How's the audio, by the way? Yeah, it's been a minute. Got some coding interviews. Let's get it. Getting right back to it. Let's see. Update the name of this title. Yeah, we're gonna do a couple Leetcode. Mertizzi, how you been? Oh, Lee, why is it in C++? Let's fix this up. Let everyone roll in. Your trip looked crazy. Yeah, bro. I was going ham. I still didn't add up the cost, but it was definitely expensive. But Mertizzi, have you been to Europe? Europe is insane. Oh, you're gonna like Europe. You're gonna like Europe for sure. Hold up, I'm just fixing my... We got somebody coming on at 8. If I had to rank them, I like France. I like Paris for sure, and I visited the south of France. That place is beautiful too. So put together. The weather was amazing. The infrastructure was just so good. The food was okay, but it's just well put together. South of France. Yeah, France, I love France. London was cool because it's just there's so many people out on the streets and stuff, like hanging out. It's super busy. And probably third, where else did I go? I mean, I'll go, my favorites was Paris, south of France, then London probably. I'll definitely go back to those. I like Spain as well, but France and London, it was just too hot, so I don't know if I fully enjoyed it, but it was still beautiful. What's up, what's up? Okay, let's hit this question real quick before this next guy comes on. So you're given an integer... Went to two hosts. I don't know where that is. Yeah, south of France is crazy. It's bougie. Pretty much after I left, 3 days after I left, there's like a video of LeBron James and Jeff Bezos hanging out 15 minutes away from where I was at. So it's expensive area. It's not too expensive. I'd say less than $200 a night still, but it's pretty much more near Nice. They were at Caen, so the city right beside Nice. Haven't been to Switzerland yet. Is that where you're from? If get me a hold of somebody from there, and we'll put them to the test. There's gonna be a language barrier and stuff, so I think that's what mostly will make that too difficult to do. Okay, let's body this first question. I haven't done Leetcode since the last submission was June 20. Dude, Europe is amazing. I really like Europe. I'm definitely gonna be back next year to like Italy, maybe like Switzerland and stuff. Where's everyone from? Who's watching right now? Where's everyone from? I see a lot of new names. You're from France? Nice, nice. Yeah, I don't know if you maybe look familiar, but I'm not even sure. New York, originally from Philippines. Nice. USA. Let's get it. Cowtown, Toronto. Nice. Are y'all like students and stuff or actual... Are y'all students or working in the industry? Like, how'd you come across my channel? Are you studying Leetcode actively? Rising Junior, nice. Okay, a bunch of students. Yeah, Murtizi is a staff engineer. Legend. Nice, everyone's just grinding. Yo, for everyone who didn't see my last video, you should start applying for all the summer internships are beginning to come out now already. So I'm gonna post like some GitHub links. No problem, bro. No problem, bro. Y'all see my latest video? I'm talking about how to apply for, or that summer 2026 internships have already begun coming out. So it's time for people to really start grinding Leetcode. Because even though this is 10 months ahead, people are releasing stuff. So somebody said, where's this guy? Someone's asking the GitHub link. So I'll show you all this real quick. But you could see there's a bunch of internships already coming out. I'm a falling senior looking for an internship. What should I do? Yo, John, CFA in the building. So you could see a lot of even the hedge funds started dropping their postings. So you can see this is summer 2026. We're in the middle of summer 2025. So if you don't get ahead of this, somebody's going to take that job before you. And look how much these jobs pay. I don't know if it says right here. Yo, run it. Run me the hacker rank. Do you have the questions? Are you in the Discord? Look how much Citadel is paying. So this is, look at this. Also, oh yeah, send it. Comment it. Or send it through the Discord. I'll try it out. You look how much Citadel is paying. $4,800 a week. Good luck, Murtizi. $4,800 a week. So it's 11 weeks. By the end of the 11-week program, you literally made 52 grand. And if that's just an internship, probably you'll get to keep all that because by the end of the year, you'll make your tax bracket won't be that high because you only made 52 grand, but you would have made it in a very short period of time. Yo, just take it. It's hard. I've done it before. It's like some math questions. Yeah, I did it. I passed all the test cases and I still got rejected. No Discord? Here. I'll send you my Discord link. Let me know if it works. Okay, let me solve this question before the first guy comes on. So you're given an integer array nums. You're allowed to delete any number of elements from nums without making it empty. After performing the deletion, select a subarray of nums such that all elements in the subarray are unique. The sum of the elements in the subarray is maximized. Return the maximum sum of each subarray. Holy, come off vacation, they're giving me this. Right away, right off the bat. Okay, let's just break it down. It looks complicated at first, but hopefully once we read through the question and work through the examples, it'll be simpler. So we're given an array of numbers. I'm gonna take some notes. You're allowed to delete any number of elements. Delete any number without making it empty. After performing the deletion, select a subarray of nums. Is it contiguous, non-empty? Select a subarray of nums. All elements in the subarray are unique. The sum of the elements. Okay, we just need to maximize the subarray after deleting. Okay, interesting. So for this one, since they're all unique, okay, that makes sense. Okay, thank you. I'll look at that in a second. So we're given nums. Since they're all unique, we could just select the whole entire array. For this one, delete the elements num0 equals 1. Delete this one. Delete this one. Okay, that's not really a good example. Yo, Paul, what's up? Damn, low acceptance rate. Okay, let me work through an example. Let's look at this one. So we should just start deleting elements off of it. So we need to delete any number without making it empty. Select a subarray of nums. Where it might be simpler than a max heap, who knows. Maximize, select where everything is unique. Okay. So what do we have here? We have 1, 2. What's the result here? I mean, we don't really need to delete anything, but this is 3. I think literally all we need to do is just delete all the elements. Like, just delete all the negative elements. I think it's just literally simple. Like, delete all the zeros and negatives. All the zeros and negatives. And then also delete any duplicates. Delete any duplicates. So we just need to, pretty much need to add up all of the greater than 0 values and just all the unique ones. So I think we just need to figure out, like, build a set of all the, build a set. Because it needs to, because we can delete any number. So it doesn't even matter. This subarray thing confused me. Select a subarray. That kind of like tripped it out for a second. Yeah, that Citadel paying their interns $20K monthly, John. GNA, what's up? Okay, so what I do is like for num. So what I'm gonna do is I'm gonna use a set. What happens if we get the result? Or what's the if there's no positive integers, what we're gonna do? So what we're gonna do is we're gonna get the best case is we get all unique positive integers and sum them. If there's no positive integers, we return the largest. If there's no positive integers, we return the largest negative or the smallest negative. The negative that's closest to 0 or 0 itself. So what we're gonna do is we're gonna have a result equals 0. So what we're gonna do is dude, even this easy question is a bit tricky. That's hilarious. For num and nums, if num is greater than 0, what we're gonna do is we're gonna result. If the num is greater than 0, what we're going to do is result unique positive. What we're going to do, if num is greater than 0, we'll do if num in unique positive. If num not in unique positive. If num is not in unique positive, if the number is not, okay, what we're gonna do is result plus equals num, else, or we don't even need an else statement. So if the num is not in unique positive, we just add this. Holy, I haven't coded in literally over 3 weeks. On Leetcode or Python. So else smallest negative smallest negative equals I write in hack, which is their own custom language. It's not that hard to write, honestly. smallest. So if we're doing the smallest negative, what we're gonna do is like float negative infinity. So if the number is greater than 0, what we're gonna do is smallest negative equals max of smallest negative and the current number. Seen positive. Something like this. If seen positive is false, return smallest negative. Otherwise, else return the result. So we can. Holy! One go! One take! Let's go. Alright, we got somebody in. We only went 2 minutes over. Holy, I thought I'd mess that up somewhere. Let's go. Yo, what's good? Yo, what's up? Oh, shit, game. Yo, what's up?
Hello?
How you doing? You're on stream, by the way, but you're not. Your face is not showing.
Okay, nice. I was watching the stream a little bit as you were solving the problem,
Yeah.
but
What do you think about that question?
it was all not too,
Not too difficult?
seemed okay.
Yeah.
A little tricky though for an easy,
Yeah.
but solvable.
Yo, chat, how's his audio sounding? We're gonna get him. Gonna run a coding interview. Thanks for signing up. This is my first
Yeah, of
one
course.
back in a while.
Actually, I want to thank you for setting all of these mocks up.
Oh, yeah.
I think it helps everyone out.
No problem. I hope it's useful. Hold on, let me just fix one thing.
I'm a little nervous. I don't think I've done a mock in front of people
Yeah. don't
besides
worry.
just like one person. But
Do you run mocks a lot with your friends to practice or not?
not like a lot. It's like we do one like one or two like a week, but it's not like a lot. It's just like
Yeah.
our routine of practice.
Oh, respect. That's how you get good.
Hopefully it pans out well.
All right, let me get my coder pad set up so I can send it to you. Where are you based again? Like, what school do you go to and like what year?
Oh, I literally just graduated. I don't know
Oh,
if
nice.
I graduated like last month, and I'm in SoCal.
Nice. Let's see.
Yeah, job market is hard. Just practicing for when an
Where'd you
opportunity
graduate
comes.
from?
UCI.
Nice. You see Irvine?
Yeah.
Nice. Okay, well, I'm gonna send you real quick. In this chat, I'm gonna send you the coder pad.
Mm-hmm. How do I open the chat? Oh,
in
never
Google
mind.
Meets.
okay. Allow. Okay.
See if you're in.
I have to do a login real quick.
Yeah. Damn, I gotta find you a good question. Wait, someone's asking how many. Oh, wait. Somebody's asking me how many mocks per week is considered good. I don't know. It all depends. I used to like to do once a day or once every couple of days with my friends. It only takes 30 minutes to 45 minutes to do a mock. So I preferred running mocks instead of like just grinding Leetcode.
It is a little. I find it a little bit more fun.
Yeah, it's way
It's
more
like-
fun like collabing with somebody.
Yeah, it feels like I'm talking to someone. It's not like
Yeah.
an alone battle.
And you get honestly a lot better. Once I started doing mocks, that's when I really got way better at doing interviews. because you only get so good doing it by yourself, like getting no feedback, no one's watching you.
Yeah, makes sense.
All right. So, hey everyone. So today I have a new grad from University of Irvine, and this is my first stream back in a month, and pleasure to be doing it with this guy. So, could you give a quick introduction for yourself, real quick?
Yeah. So I'm Lester. I recently just graduated from UCI with a SUI major.
Nice.
Just out here looking for a job, just applying, and then also just practicing and running mocks as we go. For when an opportunity comes, I'll be ready.
Yeah. How many companies have you applied for, or how's interviewing or the job market for you right now? Like applying, interviews, everything.
It's I'm not getting too many callbacks. I'm in like the 500 application number,
Wow.
and I had a couple. I had two of them, like last month. One was for a what's it called? Like a construction company, and they're like trying to open up to the like sector, as they said. I interviewed with them. It ended up being a rejection.
What'd they ask you?
They
Leak
asked
code?
me.
Or no?
It was one Leetcode
No way.
medium.
For a
It was a
construction company? That's hilarious.
I know. I thought it was a little crazy, but yeah, it was a random construction company. If you've heard of what's it called? Oh my god, I'm forgetting the name already.
Bro, that's just hilarious. People are always like, yo, companies are not asking leak code, etc. And then people come on here like, yo, I was doing construction or I was doing this random company and they're still asking leak code. So I think, honestly, leak code is fundamental. It's not the only thing you should be practicing, but once you get leak code down, you don't need to worry about nothing after that.
Yeah, I think it's still everywhere. They
Yeah.
asked me LCS, or longest common subsequence,
No way.
and I was not really good with 2D dynamic programming, so it kind of cooked me.
Yeah, I mean, even Google, like Google's pretty much the only question that would ask that question, and they don't really ask like a 2D dynamic programming questions that often. That's actually so funny.
Yeah. Oh, but my other one, I'm just waiting to hear back. I had it last week, and it was a phone screen for Amazon.
Nice.
So that's my
Yeah.
go for practicing.
So how many leak code questions have you done?
It's around like 140, up or down like 30, because some of them I just solved on Leetcode, and I didn't transfer it over to Leetcode.
I see.
Yeah.
So what's sort of your breakdown across the different patterns? How are you with arrays?
Just to I as for how I am with different patterns, I'm pretty good with arrays, two pointers, sliding window, trees, sometimes with heaps, or I just have to recognize that it's a heap problem.
Yeah.
I think I put way too much focus on graphs. So like I think BFS and DFS is
Just
pretty
light work
much
for you?
yeah, but I'm really really bad at linked lists and binary search. I just can't
I see.
or it's not about like the concept of binary search. It's like sometimes you know how you have to kind of think outside the box and find what you need to binary search.
Yeah.
That's like the hardest part. It's like, for example, like Coco eating bananas.
Yeah.
It's like it's hard to figure out. Like I had to take the range of the time he took to eat bananas. I forgot what the problem was, but
Yeah.
it wasn't just like, oh yeah, you have to binary search this.
Yes, there's like two types of binary search questions. There's one you're given an array and you literally just have to keep chopping the search space. But then there's other ones where you're searching for something, but you do it in like a binary search way. So you're searching for a specific value, and then you're like, oh, let me try this, and it's too high, so you have to try something lower. So those ones are harder to find out. Okay, I think that's good enough context. I think I'm gonna come up with some questions for you, and I'm gonna post it in. Pause this quick. find a good one.
Mm-hmm. No problem.
He goes to University of Irvine. What proficiency is the goal for an intern? Full Peralta 75? No, I'd say Peralta 75 list is... Some of the questions are a little more advanced. I would say just basic blind 75 or Leetcode.
I don't think I would do the. How important do you think bit manipulation?
I've never had to do that in my life, but I just
Okay.
do it for fun, but it's not something
And math
that-
and geometry.
Yeah, I just do those for fun. But I if I was deep into studying, I wouldn't waste my time there.
Mm.
Hold up, let me find. Need a good question. Okay. Got a good one. All right, I got the first question in.
All right, nice. I'm ready.
Well, so we're gonna do 1 to 2 questions. We're gonna spend up till the hour, top of the hour, so we have 45 minutes to just run through some questions. So if you get solve this one quick, we move on to the next one. I'll give you probably around 20 minutes to solve this one.
Okay.
So I'll quickly explain it so that the viewers can understand it as well. But let me just format this. So we're going to be given an input string S like this. We need to pretty much reverse the order of the words. A word is defined as a sequence of non-space characters. So the words in S will be separated by at least one space, like this. And we just need to return the words in reverse order concatenated by a single space. So you can see, example 1, the sky is blue. Once we reverse it, we go blue is the sky. So blue is sky the. So, yeah, simply just reverse all the words. Mm-hmm. Or like take the sentence and reverse it.
Okay. Gotcha. So, the first thing that comes into mind. Oh, am I good to go? Sorry.
Yeah, you're good to go. Yeah, for sure. 100%.
Okay. Just for like clarification as well. Will the input ever be empty?
It will never be empty.
Okay.
There'll
So
always
there'll
be at
always
least
be-
one word.
At least one word. Okay. Let me think if there's any more edge cases that I might have to think about. The first thing that comes into mind, I wrote it down really quickly here,
Sure.
is I'm going to split the string, and that will give me an array of all of those. Split the string with a space, so that'll give me an array of all the strings within there, within S.
Yep.
Then, I can do a for loop of the reversed. So like I would do a splitted string would equal S dot split. Then for that, this will give me an array of I'm gonna take example 1 as my example for now. So it'll look like this, and the array is gonna end up looking like so. And splitted string is gonna look like this. Then I'm gonna have a returning variable, and I'm going to run a for loop of this splitted string going backwards, and then I'm just gonna be appending to this return, appending to this return, or concatenating is the better word.
Sure.
While adding a space, and then after the for loop is done, that should be the reversed, split it or reversed order of that string. So for example, just to like kind of have a little bit of pseudocode. So each word in splitted string, while it being reversed, you would get the returning a string, then you would add. Actually, I would need to do the first. I would need to add the first word first. So I would actually do splitted. I would need the first word here. And this should be in the range now. So this is me going to go through it backwards. Does the solution I propose make sense?
Yeah, it's making sense so far. Let's continue.
Okay. Then, and this is pretty much me going in reverse index instead of the actual element now. Then I would do, first I would need to add the space, then these splitted, or these, the word in splitted string in that index. Then after this for loop runs, this should be -2 actually. So I would stop before the last one. And this should be, I think, the answer.
Okay.
And just to kind of run through it, like before I even code it up. So going through this example. So ret on the first iteration is gonna look like, oh, I already see a problem. This should be -1. Ret's going to be blue. Then to add a pointer here should be I. I is going to be -2 right now. Then it would.
I think I get it. It makes sense. Let's
Okay.
write out the code and then let's run through the code after to see
Okay,
if it all
no
works.
problem. Okay, the input's gonna be S no matter what. Okay. Um. Okay. I think this should be it.
Okay, so we split the string. Okay, what's your range length of? Okay, dry run me the code.
Yeah. Okay. So I'll start it over here again. So I is going to be ret when I first start it is going to be blue because I'm taking the last index. Then the index pointer or number is going to start at is, and I'm going to be appending that with the space is. Then after I append it, we'll go back to -1, so it'll be -3. Oh, this should be 1. And I think I'm overcomplicating this. Oh wait,
What's the
sorry.
other one?
I think I have a cleaner way of doing this instead of going backwards like this. So, I'm going to start again at 0. Then I'm just going to take the reverse of the splitted string. And then I'm going to append the word.
Nice.
Then I'm going to, since when I first append that word, there's going to be a space in the beginning. I'm going to return, 1, or like at starting after the space, because this will append first.
Okay.
Okay, now I'll do another dry run real quick.
Return outside of a function.
Should I just print the return instead?
Or if you run the code, it's not working. Or yeah, you could just print it, or you could do a return as well.
And then I could set it equal to this string. Okay. And I think
It's missing out.
wait. Blue is
Sky the.
blue is sky the. Maybe is it printing my the twice? Oh my god. This should just be empty. Yeah.
Okay. What's your time and space complexity?
Space complexity for this is going to be O of n for the amount of words that are, or the length of the string. And time complexity is also going to be O of n, since it's going to be O of 2n since I have to go through the array twice. But asymptotically, it's going to be O of n.
Okay, so time equals O of n. Space O of n, you said, because it has to create that.
Yeah, it has to create this splitted string array.
Yeah, let's see. Okay. I think the time complexity is actually worse than O of n.
It's
Like,
worse.
it might
than
be
O of n?
it's actually O of n squared. Like, could you look into and figure out why?
O of n squared.
It has to do for the. Okay, I'll give you like a couple seconds just to look at it, and then
If
I'll
I
give a small hint.
Does reversing
No, that's just O of n.
is splitting O of n squared?
Yeah. It's on line 50. So strings are immutable in Python.
Oh, concatenating isn't O of 1.
Yeah, because strings are immutable. That means you can't change it. So it will need to create a new string with the word attached to it.
Oh, I see.
You know what I mean? Do you get it?
Yeah,
Why-
yeah.
Yeah.
Yeah, you have to create a new one. So it's gonna repeatedly. Okay.
Like if I have a string that says a bunch of this, right? And then
Yeah.
all I wanted to do is just add 2 to it. We'll literally need to create a new string, copy over all of these numbers or all these letters, and add 2 in. Because
Yeah.
we can't just, it's not like an array that you could just append to it back. So in order to create this, it's literally O of n. So every time, so this is essentially like almost an O of n operation. Worst case or O of n operation here. And you're doing this this loop runs O of n time, which leads to O of your time complexity is actually O of n squared.
Mm-hmm. Okay, that makes sense. That makes sense. Now I'm thinking that means I'm thinking of trying to figure out a way um to make it, because I'm pretty sure there's going to be a solution that's O of n in this case.
Yeah.
Um so hmm I'm trying to think of a way where I can create the full word pretty much in one iteration then. To do this in one iteration. So currently I have this as my splitted string. And if I do a reverse, obviously it'll be backwards. Would I have to if I use a linked list? No, that would still give me the same problem. Sorry, is it if I do something like do you know if something like this is O of 1 or
Well, it's
O of n?
that's O of n. That's O of n.
Okay.
I'll give you a small hint. Also, it's like,
Mhm.
or here. Let me see. Let me think of. So what operation is actually O of 1 adding to the end?
Adding to the end.
Like what data structure can we achieve O of 1 or O of 1 appending to?
A list. A linked list.
A list or linked list?
Yeah.
Okay. Pretend we had a list of all these words.
Mhm.
How would we combine that list into the final output?
Combine that list into That's why I'm having trouble because um because I can make a list uh um once I have it backwards, how would I all at once make it into one word? Is there a Python like keyword for this? For
Yeah. Like how would you convert an array to a string usually in Python? Have you ever done that?
I should have, but I'm not sure like what if I do this.
Have you used the
If I
join operator before?
oh yeah.
That should
Oh
be
my
O of
god.
1. O of n, I mean.
Oh, Okay. Well, so can I just do like ret is equal to splitted? Is this the negative? Wait, is this what makes it go uh reverses it?
Let's see.
Because I know there's a way to index it so that when you use it.
List object has. So hop into the AI assist and ask it how to use join. There's an
Okay.
AI assist near the program output on the top right. So I can see what you're
Oh,
saying here.
on a list. Oh,
Yeah.
okay. This should be. I see. With this. All right, nice.
Blue
It did end up.
is okay. Is there under any other edge case that we need to handle? Like take a look at the yeah, like what other edge cases do we need to handle here that you may have missed?
The leading white spaces or trailing white spaces. So I would also have to do dot strip.
Okay,
Dot strip.
nice.
And I'm forgetting all the string. And then um will the dot split take care of a triple space within, let's say for example, number 3? Does the dot split take care of 3 spaces? Or will there be an extra
I think what for what yours would do is it's gonna create a. It's pretty much
an
gonna
extra
look like good, then like
an empty?
empty,
Okay.
something like that. It might do something like that because you're specifically splitting on single space.
Okay. Gotcha. Okay. Um
So I'm pretty sure your thing. Yeah, you're right. It might break. Yeah.
yeah, okay. So to deal with the dot strip will take care of any leading and trailing white spaces. And to deal with a triple space, um I'm thinking if I should iterate through the entire string again and see if I count more than one white space to change um I see. Okay. Now I'm thinking instead of using the dot split method, I'm just going to create it myself.
Well, let's use the dot split
Dot
for
split.
sure.
Okay.
Okay, look into the API of dot split. Ask here. Let's talk this. Give me the API for dot split.
Okay. Um
Yeah, take a read at that. So split doesn't take in regex. So somebody asked in the chat, does split take in regex? Not the default one on string, but you can import regex and split on a specific pattern. But we don't need to do that complicated. Let's just use the simple string split and just take a read at the API to figure out how you can do that.
So the delimiter. Max split to basic split using white space. Consecutive white space is treated as a single. Oh, so I shouldn't. Okay, so I should just remove the the pretty much the single space. So any consecutive white spaces won't be counted as multiple.
Yeah, exactly. for the chat, because people are asking, the chat says split. What split does right here? It's pretty simple. It's like split. Like it was only breaking because you specified the delimiter, but by default it will split any consecutive white space. So yeah, now it works if you just remove that.
Okay, nice.
And run it. Nice. All right, let's move on to this. Let's move on to the second question.
This is a good reminder to think about all of my string syntax keywords.
Yeah, just memorize those. Just get used to the public or the standard library utility functions. It'll help speed that up. But these are classic ones. You don't need to really know much more than that. All right, question 2.
Okay.
So we're going to be given the root of a binary tree, and the binary tree has unique values. We're going to be given 2 different values and 2 different nodes in the tree, and you just need to tell me if these 2 different nodes are cousins in the binary tree. And then 2 nodes are cousins if they have the same depth but they have different parents. And I'll let you go ahead and clarify that. I know it's probably confusing right now, but I'll clarify any questions you have.
Okay. So given the root of a binary tree with unique values and values of 2 different nodes of tree X and Y, return true if nodes to X and Y. So it is 2 different trees. And will both trees be...
No, we're given one we're going to be given the root of one binary tree, and then we're going to be given 2 separate nodes in that tree.
Oh, okay.
And you just need to tell me, are these 2 nodes cousins in the binary tree?
Okay, gotcha. Yeah. So first thing that comes into mind, since we're looking at depth, since they don't have to have the same parents, and it's fine if they do have the same parents, they're still cousins, I assume.
If they have the same parent?
Yeah.
If they have the same parent, they're siblings, they're brothers or sisters or whatever. So they're not cousins. It says somewhere there in the prompt.
Okay. So there's 2 ways that comes into mind when solving this problem. It's gonna be running 2 depth first searches, where you would just you would think about how far deep into the tree you're going to be going, and you'll keep track of the parent as well, and if their parents are the same, or you would, once you reach that node, Um. Oh, that wouldn't work. Okay, I think we would do a BFS on this, and then, so on every iteration, we'll be looking at the level, and if we find X, then we're forced to find Y in that exact same iteration for that while loop. And if they don't end up being in the same while loop, then we'll return false. And we'll also keep track of the parent. And if the parent's the same, then
Did
then
you
we will
write that
also
down?
return false.
Sorry,
Yeah.
I forgot what you said.
So it's going to be a BFS.
Sure.
Then we're going to be keeping track of two things. So once we find either X or Y, we'll keep a note of either one of their parents. So keep note of X's or Y's parent, because we have to make sure they don't have the same parent. Then it's going to be some sort of Boolean found node. And if we go on to the next level after finding X or Y, so once we go to the next level, once finding X or Y, we will return false, because that means they're not on the same level and they're not cousins. But if we find both of them on the same level and they have different parents, then that's when we return true. Does this sound good to you?
So we're gonna run a breadth first search.
Mm-hmm.
We're gonna find X or Y. Once we find that, we're gonna just store it somewhere, and we're gonna keep going through that same level, looking for like the other one. Okay,
Mm-hmm.
I think in practice it makes sense. Let's go ahead and start implementing. We could work it out after.
Okay. So okay. So while Q, then Q is going to be a deck. Q dot append root. I'll assume the root is going to be the input. Then current node will be equal to, I'll just write cur root Q dot pop left. So for all of the things in the queue, for all the elements in the queue, and this will be the parent. Current will be the parent for this. So if cur dot left,
Let's turn this into a function that accepts what we mentioned here, which is the root and then the X and Y.
okay, so okay. So once we're at this point, we're going to see if we find X, cur dot left is equal to X, or if cur dot right is equal to Y. Or wait, this should be Sorry, this should be lefted. This should be right. Then the parent and cur is equal to parent. So once we find either x or y, for this, we'll be looking at, this is going to be the same level, then okay, so once we're at this point, if cur dot left is equal to x, if cur dot right is equal to y, then we would say I'm going to have another variable called found x and found y. This should be then found x is equal to true. Then found y is equal to true. This should be outside of this, actually. So that on each level will be looking at this. I feel as if I'm messing up the implementation of this.
Because it might be a little bit overcomplicated.
Yeah, I feel as if I'm overcomplicating this. Because I just have to check if I found them here and if I found both of them, then we return true. But I have to make sure that they don't have the same parent.
Yeah, exactly.
And this isn't going to look the prettiest, I think. But I'm sure there's going to be a way cleaner way of doing this, but this is just going to be keeping track of the parents, essentially. And if they don't equal each other, then you can safely say to return true. But so now,
What if they what about the same level?
this should work if they're on the same level. Now I have to figure out if they're not on the same level. So if found x and not found y, or oh my god, or if found y and not found x. So this will this if statement will check if we find one of them and we end up not finding the other one. That means that they're on different levels, so they're not going to be cousins.
Mm-hmm.
And right here, if parent x is equal to parent y. Okay. So now here I check if they have the same parent. Then I would return false.
Okay.
Excuse me. But now I have to do if. This is a really big if statement. Or if tree. Okay. I'm thinking if there's... I have to figure out a way to clean this up.
Yeah, how would you clean this up?
If the root node...
Yeah, there's a lot of conditions.
Yeah. Root. Okay. I don't need this. But I think there has to be a way where I don't need a...
Okay. We're have like a couple minutes left.
Mm-hmm.
So let's just stop it there. How do you think you did?
I did mediocre at best, I think. Just because of I think especially for this question, I think I didn't talk through, or I didn't write down at least what my thought process was. And I think I need to flesh out the solution a bit more before I start coding it as well.
Mm-hmm.
But at least for the first one, I think I was able to come up with a an algorithm pretty fast. But it was mainly like I didn't know about, or I didn't find the dot join solution, which does bog down points as well.
Yeah. Yeah. Okay. Let's look at this first one. I think some of my feedback is I do like how you're clarifying the question and the way you're brainstorming ideas. Honestly, by the time you write the ideas, it sounded like you knew where it was going. But I think when you got started coding, a lot of the times you overcomplicated things. But I think even this solution is a bit overcomplicated. Or it made sense
Yeah.
here. Is once we find, so keep notes of the x or y's. Once we go to next level, like return. I think this one we could probably simplify this a lot by just saying like a root. Maybe we could start with like a root at level 0, and maybe x, for example, x equals none, y equals none. So maybe remove all of this right here. Like if we just did something like if, or we'll do current equals q dot pop left current, and then the level. What we could do is if the current equals x, right? What we could do is store in x the level, and then yeah, how would we get the parent? Similar to like if we could just keep track of the parent, maybe when we're appending here. Let's see. Do you have quick resources? But I think overall it could be simplified. I think the hard part is grabbing the parent. Let's see how we would do that. But I think when we're like when we see a value here, we could just append it. We could maybe just have like a parent map that maps like each node to their parent. And then once we find x and y, we can maybe just store the level of x and y and just eventually just like something small at the end, like is x level equal to y. So something like current x. We'll just store x equals level. Does that make sense?
Oh, I see. So once you find both, so you're gonna have pretty much like a hash map, and then once you find both,
And parent.
yeah.
And then like while we're going through this, we could just have like a parent map that kind of just maybe maps back to the parent or something like that. So it's like I think coming up with. I think yours made sense. You just kind of overcomplicated and wrote a ton of code. But I think you're getting there, but just all the conditions were too much. I would have just took a step back.
Yeah, that I definitely knew like the moment I started writing more than 4 if statements, there is definitely a way better way or cleaner way of solving it. Do you have any tips on like finding that intuition?
See, let me get back to your code. I think you're getting there. It's just any tips for finding that intuition. Did that solution kind of make sense where you like just store the parent map and then eventually see? And I think here one issue would be the default. Pretend none of these conditions ever hit. This will just return none here, but we're supposed to return like it implicitly returns a none. So if none of these conditions ever hit, it's just gonna return none, but it's supposed to return true or false. So I'm not sure if this algorithm would work on every edge case.
Assuming that the x or the y is in the you can guarantee that it exists in the tree.
Yeah.
This will always execute a true or a false, because if I hit one of the x or the y's and then it goes to even like a different level, it'll return a false.
Where's your
So as
found
long-
X and found Y? It's not. Did we delete
Oh
it?
no.
Okay,
Yeah,
you
it was over
okay.
here.
Okay. Yeah. I think it would just be. I honestly your coding skills is pretty good. Like you're able to come like it's very complicated. Like it's overcomplicated. So with just practice, you just need to drill it down and simplify it. But you said you only did 150 questions, so I think you're able to get there. It's just more you just need to like aggressively simplify it. Like if when it gets too complicated like this, you just need to take a step back and figure out how I could do this in a simpler manner. Honestly, it's gonna be hard to do that on the fly in an interview, but that's why you have to just practice a lot before your interviews to just make sure you can pump out clean code.
Yeah.
Because if you gave me this algorithm like this, it would be even hard for me as an interviewer to just make sure it's correct. Like it'll give me a hard. You're gonna be giving me a hard time validating your algorithm.
Yeah. And if it's hard for you to validate, I mean, I feel like
Yeah.
there's not much of a reason for you as an interviewer to give me a higher sign, which
And
makes sense.
anyways, like if you even run into any issues here, it's gonna be really hard for you to debug, especially on the fly. So it's
Yeah.
important to write clean, concise code. But it all just comes with practice. Um, so I think with the second question, that was my feedback. For number one, I think yeah, you clarified it well. You overcomplicated it a bit because you're doing you were doing that weird thing where you're initializing the return with some value, like the zeroth element. Then you would try to start the for loop, or like the second last element instead of the first, and instead of just writing the loop to start from the last
Yeah,
element.
yeah.
So see, that's what I was saying. Like you're kind of overcomplicating it. Like that yeah, like you could just simply just have like started at the last element and went backwards. Um, I think you just need to look into the utility functions just make sure you know the common ones. I think join is very common. You'll see that a lot. So make sure you understand the join function, and then analyzing the runtime complexity. I think you know how to analyze the runtime complexity, but that immutable string caught you.
Yeah, that definitely I need to remember that because I if there's ever any time a string function or like a string type problem comes up in Leetcode or like a Leetcode string problem, then they ask me that question, then I respond to them that it's a O of one operation appending to a string that might give red flags.
Yeah. Okay, what else? Yeah. I think just making sure that you write code that captures all the edge cases at first. You weren't capturing the multiple edge cases or multiple spaces and trailing. But eventually you were able, once I prompted. And I think that's fine for new grad, but as you get more senior, you should be able to catch edge cases and address them. Like the interviewer shouldn't have to point them out, but I think for the level you're interviewing at, that's perfectly fine. Yeah. But I
Nice,
think
nice.
overall for actually yeah, like I'm kind of the way that I give feedback is I usually only interview senior candidates at my jobs. I've never interviewed really a junior candidate, so all my feed like take it with a grain of salt because yeah, you did pretty good for the level that you're gonna be interviewing for. I would just make sure to write clean, concise code, not buggy and capture all the edge cases. Other than that, your process was good.
Okay, nice. I think I just really yeah. When I started writing it out, I knew that low key it was yeah, not looking the best.
All
So
right, cool. Thanks
okay,
for taking the time out. I'm gonna have to hop to the
yeah,
next guy. All right,
yeah. Thanks for taking this from
no
me too.
problem. Good luck with everything,
Mm,
and keep in
thank you.
touch. Okay, peace, peace.
Bye bye.
Nice. All right. Yo, chat. How do you think he did? We're gonna move on to the next person. Dustin. Let's go. Yo, Dustin, what's up? Sorry for being late. I was running with the last person.
Yeah. Sorry, I had to mute your stream real quick. Say that again.
I was running. Like yeah. Sorry for being late.
Oh, yeah.
How you doing?
I'm doing good. Yeah. It's 12 a.m. for me. I'm kind of tired, but
All right. Yeah. This is my last one of the day too. So let's take a look at what you submitted. So you go to University of Florida, solved 81 Leetcode questions
yeah.
based in Houston, Texas. Cool. What year are you in university? Are you gonna graduate soon?
Yeah, I'm a rising senior right now.
Okay. So you're looking for new grad positions.
Yep.
kind of thing. How's that going for you? Have you done internships before?
Yeah, I have done two. I'm doing a remote one right now, and on top of that, a government one for a database
Nice.
thing.
So how are you feeling for actually getting a job after you graduate? Are you confident like maybe one of your internships are going to be converted?
No, I think I need to go on the search for that for new grad. I don't think I'm getting a return offer because the remote one I'm having right now is going through some financial troubles. So I don't see a return offer for that, and the government one is not where I want to locate right now. But yeah,
Yeah. I mean,
yeah.
if you saw my latest video, I was talking about how a lot of postings, even for summer 2026, are starting to come out. So I
Yeah.
think even for you, you should. Good thing you're starting to prepare now,
Mhm.
but you should have your resume ready by then this summer. And then September, October, November, you're gonna see new grad postings. You gotta start applying ASAP. Because if you wait till
Yeah.
January, you wait till December, it's gonna be tough. Or you're gonna miss out on a lot of positions. People would have already taken them.
Yeah.
Yeah,
I have my resume ready and everything. I'm just practicing my Leetcode right now. So
nice.
it's been like the past 2 summers I've been grinding like 81 questions. So hopefully I'm ready by the time applications open up.
Yeah. So, okay. How are you with the different? Is there any? I'll just ask like, is there anything that is not fair game? Like you can't do linked lists. You don't know heaps. You don't know.
I can't do
Where's it going?
dynamic programming or
Okay.
yeah, I haven't learned that yet. But yeah,
Okay. How long have you been on the stream for? Like since the start?
since like 30 minutes ago, I've been listening to the other guy a little bit
Nice.
since he solved like the problem too, kind of.
Well, like since was solving the leak code.
No, since the last guy was solving the Leetcode. Last problem
Nice.
too with the cousins.
Okay. Sounds good. I'll throw in a question.
I was wondering if I could change the language to. Can I change the
Yeah.
language?
Yeah. Go ahead.
Yeah.
Go ahead. What language?
I use C++. Honestly.
Nice.
Okay. Yep. I actually don't know how to use this, but okay.
All right. Okay, I'm gonna throw you the very first question. We're gonna go through one or two questions, depending on how fast you solve it. We're gonna look for code that runs, and we're gonna just ensure it runs.
Sounds good.
This is the leak code of the day. I don't know if you solved it yet.
No, I haven't done a Leetcode today yet.
So okay, you're given an integer array of numbers. You're allowed to delete any number of elements from from that array without making it empty. After you perform the deletions, select a subarray of nums such that 1. All elements in the subarray are unique. 2. The sum of the elements in the subarray is maximized. So we need to return the maximum sum of one of those subarrays. And I'll post in a bunch of examples. And then I want to see how you think through it.
Okay. Oh wow. Okay. Ooh. Okay. You are given making it empty after select a subarray of nums such that okay, all the elements in the subarray are unique and the sum of the elements in the subarray is maximized. So I'm guessing we just sum up whatever left we have in the subarray, right?
Yeah.
Yeah. So let me look at example 1, 2, 3, 4, 5, and then 15. 1 plus 2 is 36. 10, 5, 10. Yep, 15. So that's the maximum sum. Yeah, that makes sense. Example 2. Okay, output 1. So okay, we'll delete the element num 0 equal 1. Okay, let me look at example 2 because 1 1 0 1 1 output is 1. Delete the element number 0. Oh, because these elements aren't unique. Okay, that makes sense. And for the last example case, 1, 2, negative 1, 2, negative 1. So I'm guessing we remove the 2's here. Actually, no, these 2's are fine. We would remove this unique 1, 2, and it would get rid of the negatives because anything negative would bring our maximum sum down. So, okay. I'm just right down here. So what we want to do is, we kind of want to go through the whole array, and we want to keep track of the unique numbers. So we want to identify which numbers are unique. And then we kind of want to delete negative numbers as those affect our maximum sum, I think. Am I getting on the right track here? So basically, if we have like 1, 2, 3, 4, 5, oops. So, so all the elements in this array are unique already, and if we delete any number in this array, it would affect the maximum sum because they're all positive. So we don't want to delete anything, so we would just return 5. But if we had like test case number 3, so we would go through this array, and then we would find that this negative 1 affects our maximum sum, and this negative 2. So we want to get rid of these 2 things, 2 numbers, 2 things, and then we also have this one that's also a duplicate. So yeah, so I'm thinking that we track the unique numbers. We could use, we would only return the maximum sum, so we could just keep track of that while passing through the array. And then we also need to keep track of unique numbers and delete negative. Yep. And 0 doesn't really matter in this case, does it? Delete the numbers 2, 0. Example 2 to delete 0. Well, it doesn't really matter because it's still going to be 1, but yeah. Right, let me see. 1, 2. Yeah, it doesn't really matter if we delete 0 or not. Yeah. How's this sound?
Let's keep track of that. Yeah.
Yeah. Okay. Am I good to code this out or?
So it's okay. So keep track of the unique numbers, delete the negative numbers, return the max sum.
Yep.
Okay.
It's not really
Is there any
deleting
edge cases?
Edge case I can think of is when the array is empty. That's one of them. We would just return 0 because there's nothing in the array. If
Assume
it's
there's
all
always
negative
one. There's at least one. Yeah.
Okay. Wait, can I see the constraints too, or?
The constraints are there's always going to be one at least, and then that's pretty much it. Like any number there could be any integer.
So if there's all unique numbers, that's another edge case. Unique numbers, and then there's all duplicate numbers, and all negative numbers.
Okay, how would we handle all negative numbers?
Oh, the sum of the elements is maximized. So we want to deal with like the minimum. We want to choose the smallest negative number. If I'm thinking, so we want to choose the smallest negative number. Is this what it means by making the maximum sum of such a subarray if we choose the smallest negative number, because that's the maximum, like the smallest negative number in this case. So if we had like a test case like -1, comma, -2, and 3, we would just return -1, and that is our maximum sum.
Yeah, that would be maximum, right? Because -1 is greater
Yeah.
than -2 or -3 or combining any of those.
Mm-hmm. And then if our positive numbers, then it's the same thing with the unique numbers, kind of lumps into the same test case.
Okay. Yeah, I think you covered the edge cases. Like, go ahead and implement.
Okay, so let's think. Okay. So let's just pass in a vector of int, and then we can just input. That's fine for now. Okay, so we want to keep track of unique numbers. So I'm thinking of a set of int, and we can call this scene. And then we also want to keep track of, no, we don't want to keep track. We don't have a running sum. Oh my. Sum equals 0 for now. Actually, because we have to make sure that our negative numbers. So this is fine for now. So let's just loop through the input array. And then so let's figure out the first case if unique numbers. So if the number we're currently at is not in our scene set, we don't add it to the running sum. So scene.contain, or we can actually just do find. I don't know what version we're in C++ we're running on, but I'll just use find. Input at I is not equal scene.n. We also have to check if it's negative, if all these elements in here are negative. So we could have, let's just keep a track of, I think we should also keep a track in the case of negative numbers if they're all negative. So this would just be a separate case, but smallest number is equal to, I think we can do min, float min, int min, and 16 min for now. But that's just dealing with the case of negative numbers. But if it's found in the scene, and then if input at I less than 0, then we do running sum plus equal. Oops, I should be able to KSN. So that would add it into our running sum if it's greater than. But let me figure out the case of negative numbers. This should work. So for all these other test cases. But let me think about negative numbers real quick.
If scene.find equals input is not equal to, then we just increase it.
Yeah, we would add it to.
Where do we update the scene?
We would update it. Oh, yeah, I forgot to put it in here. scene dot push, no, insert push. I think it's insert. Input of I. And then let's just say if our smallest number. So let's just say we have a couple test cases here. So and then -5, and then we have another test case of -1, -2, -3. So in this case, so for the first case, we go through here. 1's not in our set, so we insert it and then add it to 1. Same thing for 2, it's not included in the input in the scene set, so we add it. 3, 6. Same thing for 3, and then -5 is also not in it, but because it's negative, it's not added to the running sum. But in the case of -1, it's not greater than 0, so it doesn't get added. -2 doesn't get added. -3 also doesn't get added in this case. So in this case, I want it to add just -1. So let's think. Maybe. So keeping track of this doesn't make sense because if we did it for this set, it would keep track of -5 and add it. So let's not do that. Keep track of the negative. I have to make sure the whole array is negative. So what we could do is -1, -2 doesn't pass. We just need to add -1. So we could just check. Okay, so we're gonna. I'm thinking like a way we can do this is just if like the running sum is 0 after the end of this. And
It could be 0 if it's all zeros.
yeah.
Or if it's like 0, -1, -2, -3.
So you're saying for the test case of this?
Yeah, what would be the answer there?
0.
Yeah.
Oh, okay. Oh, because it adds it, so greater than or equal to 0. So, it's done.
So which part are you kind of trying to work through, the negative number case?
Yeah, I'm trying to work through the negative number case, because in this case, I know we have to. So after this code runs, in this case, for the second test case, it will return 0. But if we had like -1, -2, -3, the running sum after this whole code, this whole execution block runs is still 0. And then I just want to add the smallest element in this negative array if the running sum is still
Okay,
Zero.
how do you know it's the how do you know if the running sum is still equal to 0?
So we just like if we just check if running sum equals 0. But then I need to find the smallest element in here. Right. Oh, I was right.
But like
here.
if the running sum is equal to 0, what if it's this case? We don't want to return -1 here.
Yeah.
In this case.
Yeah.
Right.
So In this case, there has to be something else that we can check. So if scene doesn't contain 0, scene doesn't, so if we can't find 0, then we can add just this into it. So does not equal scene dot end and scene dot, no, it's not scene, it's running sum equal to 0. Then we can just say running sum equal to the minimum element, and we're to keep track of the minimum element. Int 32 min. Equal, I'm just kind of slow. Was it the minimum? The minimum of smallest number or input of I, because this covers the case where it's less than. This is all the negative cases, and this should run. So this would equal smallest num. And then return running sum. So this should work. So let me just run through it. So 1's not in our scene. So we insert it, and running sum is 1, 2. So then 1 plus 2 is 3. And then 3's not in our set yet. So 3 plus 3 is 6. And then negative 5 works. And then this case. And then 0 is not in our test case yet. So 0 plus 0 is fine. Negative 1 is fine. We just skip over it. We just keep track of smallest number. And then negative 2, and then negative 3.
What does this do right here? If scene.find is not equal to...
It just checks if 0 is in our scene set yet. So it just keeps track of if it's like this test case where it's all negative. But if it's a second case where it's 0, then scene.find at 0. So that means, it should be equal scene.end, because that means it's, wait, no. Yeah. If it's scene.end, that's true. So it doesn't exist in the set yet. Oops.
I mean, let's run it through some test cases because, you have some good test cases from line 47 to 50.
Okay. So how do you run this with a test input case? I'll just call it down here. We can call 0, comma. This should run, right? Or no? Wait, do you just want to do a dry run, or do you actually want to run
Print it. Yeah, let's get it working.
Okay.
Print it to the console.
Let's include set. Type int. RGV, RGC. Wait, what? RGC, I mean. Okay, so let's see if this runs real quick. No, it wouldn't run. So let's just make input here. Enter int input equal. Okay, that should work.
Couple errors.
Comparison of integers. Long unsigned. Oh, I can just change this to just a quick hack so we can get this running. We can just output that.
Nice.
Okay, so negative 234. Oh, it should be max instead of min because this is a bigger element. This is just in 32 min.
So what did you pass in 0, 1, 2, 3? I mean, this should return 0, right?
Yeah. So plus equals. So it's going to this test case greater than or equal to 0. It's going to this case 0 dot find running sum equals 0. So this is true.
Yeah.
And then scene dot find 0 doesn't equal scene dot end. That means it shouldn't. If it finds it, no, it should be the same case as does not equal scene dot end. Cause
Okay.
yeah,
That worked.
there you go.
Try out the other cases.
Mm. One, two, three, negative 5. So the answer is this should be 6, 0. Smallest num plus equal 1, 2, 3, and then running on the smallest number. Okay. I. So when 0, 1, 2, 3, and then smallest number input. Okay, so 1. So it's 1, 2. Else negative 5 is smallest number. So running sum. So when 1 gets passed into here, it inserts it into our set greater than or equal to 0. So that means it's greater than. It'll add it. So it's first 1, and then it's 3 after this test case runs, and then plus 3 again, and then it's 6, and then when it hits negative 5, call smallest number is equal to the max of that, or negative 5. So smallest number equal negative 5 here, and it doesn't find scene.n, but running sum equal 0 is false because running sum should be 6 in this case.
Yeah.
So put I.
You feel free to run the code as much times as you like. Like, how would you debug this?
So the test, I feel like when it's 0, it should be, well, this, the only thing I could see running wrong is when it hits -5 and when this else statements get hit. So
But it's returning 0.
mhm.
So it doesn't seem like it's updating the running sum properly, is it?
Yeah.
Because running sum is only being used in these. Pretty much being set
Running
in
sum
three
here,
two
but
different
it should be, it's not like affected by scope, is it? So let me see. Let me just output running sum here. See what it's giving me.
Make sure it's actually getting there. It's good.
Because I'm pretty sure it should be hitting the running sum here.
Looks like
0. Is it not saved or something? Why is it? What's it hitting 0?
What's input?
Is-
Where's input? Okay, input.
Input is this vector right here. Why is it still 0? If input is greater than equal to 0. At I, yeah.
Okay, so is this not evaluating?
Yes, this isn't evaluating. So this if statement up here isn't allowing it to be run. So scene.find input does not equal to scene.n. Oh my, honestly. Dot find. It should be equal scene.n. Oh my. Because if it's not in there, it should be equal to scene.end. So it just runs the whole array of the whole set. Yeah.
Nice. Okay, what about the negative case?
The negative case, -1. -1, -2, -3. So 0. So in this case, -1, -2, -3. Running sum is 0. I'll make the smallest number. Dot find equals so this code is not getting activated. So should be equal scene.end. So then it reaches the end of the set too. We should hit. Yep, -1.
Okay, just test like this 0, 1, 2, 3 one last time. Okay, sounds good. Nice. Okay, we have 20 minutes left, so we can try to go for a second question.
All right.
I'll pull it up 1 second. How you feeling about that?
Yeah. I think I was on the right track, but then I got stumped. I confused myself over the conditions.
Yeah,
And then the edge case of I was on the right track of keeping track of the smallest number, but then I second guessed myself and then removed it. Yeah. Overall, I think I was on the right track though.
Mm-hmm. All right, We're gonna go into question 2, the last question of the day. So let's just reset this, or let's just add another tab. This is the same one. Reset tab. Okay, putting in the second question. So we're going to be given the root of a binary tree, and the binary tree has unique values and an integer start. At minute 0, an infection starts from that node. And at each minute, pretty much it infects all of the adjacent nodes. So each minute a node becomes infected if the node is currently uninfected and the node is adjacent to an infected node. So we pretty much just need to return the number of minutes until the entire tree is infected.
Okay. Is there some test cases? All right.
There's no test case, but we can work out.
Okay.
We can work out.
So my first question is, does an infection start at the root?
No, it's gonna start at this integer start.
Oh, so it doesn't have to specifically start at an integer.
You can start at any node. We're essentially, let's just simplify this. You're given a root of a binary tree with unique values and a starting node. At minute 0, an infection starts at that
starting node. Okay.
Each minute a node becomes infected if it's currently not infected, and then it's adjacent to an infected node. So there's a drawing mode here. So if you wanted to draw it out and ask me questions, clarify, we can work it through there. But yeah, I'll let you go.
Is this? Oh yeah.
Yeah,
Okay, so each node is unique, right? Yep, unique values, and it's a binary tree. So I'm gonna just draw. Actually, I'll just don't need the circles.
Yeah.
I think this is a good test case. Try. So if we can start at 2, if the infection starts at 2, we would have to explore 4, 5, and 1. And then the next minute we would explore 3, and then return that. How many minutes it has? But I think the first thing we need to do is find the infected node. So we would have to go through the tree first.
What is this 0 right here?
I try to draw a circle first.
Okay.
It's not.
You just gonna delete that one? Okay.
Yeah. But,
so we're gonna be given a start, and it's gonna be like 2.
Mm-hmm. Yeah. So let's say our start is 2.
Yeah.
Start is 2. Yeah. Start is 2 right here.
Mm-hmm.
And then we would expand outwards. So we go to 4, 5, and 1 in the first minute because that's all adjacent to this infected node, right?
Yeah.
Yeah. And then in the second minute, we would go to 3. And that's it.
And then how much minute? What should be the answer there?
So the minute 0. So when it first gets infected, so this is minute 0, right? So when it first gets infected, so then it should be minute 2.
Okay. Yeah.
Right.
Makes sense. Yeah.
Okay. So first we need to find the starting node that it's starting at. So we're gonna do a DFS first to find, like in this case, we will find 2. So, and then once we find 2, we would have to do a breadth first search, and it would have to go backwards, and then from there we would
breadth first search backwards.
Let's think. We would not breadth first search. We would have to do a breadth first search from 2, and it would have to go back to the parent, and then from the parent we would have to go back to 3. So I don't think a recursive solution for doing the BFS is easy. So would in the case, how, like, are we going to implement this binary tree?
Yeah.
Okay, so can we
I mean,
yeah, no.
we're gonna be given the
Mhm.
binary tree, like class. It's gonna look something like. I'll show you. I'll drop it in the comments. We're gonna be given a tree node class, and it's essentially gonna be a struct like that. In C++.
Okay. So I'm thinking we do a DFS first on the tree, and then we do a breadth search on from 2 onwards. So then we would somehow have to keep track and go backwards from 2 and revisit 1 again. So I think if we do it iteratively, we do 1, 2 stack or queue. The entire tree to be infected. So we find 1, go down to find 2. Then from 2, we would have to go back up to 1. So we curse backwards. We would undo it once we find 2. Go up the tree. So in this case, we would have to 1, 2, 3. Okay, so DFS first, and then outward back up. So could we do a recursive case? If we go back up here, can we tell it to go down here? Or is this backtracking? I'm kind of lost on how we would explore like backwards up to the tree.
Yeah.
Nice.
So we're given a tree like this.
Mm-hmm.
So yeah, what are your thoughts on? So what's the problem? So you want to breadth first search from here?
Yeah.
So.
But like
Yeah.
our tree node structure only allows us to go to the children, left, right, and doesn't allow us to go back up into the theme. So like if we do a recursive DFS from here, like we would go, like if we did like from 1, then left 2, we start here. We explore 4, 5, and 1. But it's how we can get back to our parent node. So let's see. BFS.
So yeah, just having. I like your initial solution where find the node, then perform a BFS.
Mm-hmm. The trouble is implementing it. So I think if we have the parent node passed into our like BFS, we could and keep track of what we visited already. That is a potential solution. That's like a potential method of doing this BFS from 2.
So we want a BFS from 2. The main reason is we have this directed graph.
Yeah.
Where we only have pointers here.
Mm-hmm.
Like how can we turn this into something where we could actually perform the BFS correctly?
We could transform it into a list, right? Or like a what's it? Was it a matrix list? Let me think. Matrix list, because then we go to. Yeah, we could do a matrix list. Right. So in this case, we could have
I'm thinking
What?
something more subtle. Like click back into this drawing mode.
Mhm.
Like what if, like it looks like in order to perform a breadth first search, we just the main problem is it's a unidirectional graph. Is there a way that we can just be able to figure out these and then we could, if we had a graph in this structure, would we be able to run the BFS you're talking about?
Yeah. So I think if we just create an adjacency list, like I don't know, I think that's the term, adjacency list.
Mm-hmm.
Oh yeah, we could create an adjacency list, and then so it'll look like 2, and it has adjacent of 4 and 5, and then 4 would have like nothing, but 5 would also have nothing, and then 1 would go
It could
to.
even be as simple as we just need to track the parent of each node. So 2 just has a parent of 1. Because with the tree node structure there, we know the left and right. So we know 4 and 5, and then we just need to keep
Yeah.
track of the parent.
Yeah. Yeah. So, and
we
then
can build a full adjacency list if you think.
yeah.
If
So
like what my suggestion didn't make sense.
With the matrix list, yeah.
Yeah.
I got the terms mixed up. But yeah. So in that case, we would still do a BFS and build out this adjacency. We would do a DFS first and then build out the adjacency list. And then from the adjacency list, we would do a BFS on it and then figure out how many times, how many minutes it would take to affect the whole tree.
Yeah.
So DFS to build out adjacency, then BFS. Okay, that sounds good. So to build out an adjacency list, we could just keep track of it using a hash map. So, and because all the values are unique, that could be our key. We could just do. Let's just do a vector event. So let's just make an adjacency list because that keeps things simple.
Mm-hmm.
Adjacency list, and then we do a DFS on our node root. Let's not worry about that. And pass in the adjacency. And we're going to pass in the parent too, so we could pass in null pointer. So we would start at the root, and the parent of the root is null pointer. And then DFS of node, current node, parent, and unordered map of int to int of. I'll just call it list. So list at is equal to okay, well, let's just check if current first is not null pointer. If current is current equal null pointer, return, and then afterwards we can check for the unordered map, so we can push in current dot list, current dot value. It's equal to Was it current right, current left, and current, or just parent? Parent. Well, we have to check if a parent is also not null pointer in this case. But we could do that differently because we could do that in the next one. So for example, so if parent does not equal null pointer, we can just have list at parent dot value.
Okay,
Equal to-
let's assume you already have a adjacency list. How would you let's see you write out the BFS.
Okay, so once we have the adjacency list, I would do it iteratively through the thing. So we would use a queue of int queue, and we also want to keep track of. Should we keep track of nodes that we already infected? Yes, we should also keep track of nodes that we already infected. Set of scene, or we can call it infected. And then queue dot push adjacency list at well, let's just call this infected value because that's what we're also going to be passing through main. And then oops. Int size is equal to q dot size. So we want to go through each layer. So if we start at 2, we'll just go through the size at ++. And then at each, we want to keep track of if it's infected. So let me think. Int current is equal to q dot top, and then let's pop it from here. All right, this should be the infected value. Yeah. So that's q dot top pop, and then we go through for auto iterator in our affected value of current. Let's also add in our infected dot push or dot insert current. And then if infected dot find equal infected dot end, let's push it into this queue. So queue dot push it, and then we should keep track of the minutes too. Minutes equals 0. And then at the end, we could just say minute plus plus, but that's later. So it goes through all the infected, and then, so in this case, it would go through 2. So it starts off with 2, and then our adjacency have 1, 4, 5. And then, Oh, wait, I don't need this for loop. Yeah, I don't need this for loop because I'm already going through the adjacency list, which has all the elements that I'm first searching through. So then,
What if there's more than, okay, if we go to the drawing here,
mhm.
what if there's like 6, 7? So the first one we knock off this. Second we knock off these. Second we knock off these. So in the third case, like, is it gonna be there? Like, it's not. Let's see. Or like in the second iteration. Like, how do you know, like, when to increment the minimum?
The minute or the middle?
Yeah, when do you know when to increment the minute?
At the end. So after it runs through this for loop, so that means it explored 1, 4, 5. And if it's so it should, after we explore these elements, then we increment the minute.
Yeah,
So
after
then it'll
we
be-
do 4, 5, and 1.
Yeah, because this is 0, and then we add 4, 5, 1. If we add 4, 5, 1, infected plus insert cur. So right now it's minute 0, and then we infect 4, 5, and 1. So that's minute 2. Oh, that's minute
This, yeah,
0, 1.
it's minute 1.
Yeah, minute 1, and then afterwards 6, 7, 3, which is minute 2.
So I think you do need that for loop in order to, like, loop through. So when you know when to loop, so when you know you're done processing a level, you can increment the minimum.
Oh yeah. Yeah, cause yeah, we have to go through the it's not just the top one.
That works on like the first level because all of
Yeah.
the adjacent ones are connected. But for the next level after, you're gonna have to process.
Yeah.
Yeah. Okay. I think we're running out of time, so let's just like let's go through the feedback. So how do you think you did for this?
I feel like I don't know. I feel like I was on the right track with the DFS and BFS, but then I kind of got lost in how to implement it because I was kind of too focused on the BFS, and then I didn't think of like the adjacency list or the from the solution set, and then after a while, I started messing up with the for loop in the code, and then I'll spiraled down.
Yeah. Okay, let's talk about question 1. So the first question was the question related to. Let me actually bring up the. So question 1 was the question around the what's it called?
The maximum subarray.
Yeah.
Something. Yeah.
Let's see. I'll just walk through my notes. So I think with question 1, you described the question well. You were able to find the right solution. You asked clarifying question, that was all good. But I think you just needed prompting in order to capture all of the different edge cases. So for the edge case around the negative cases, so I prompted you on that one, and also the negative case if there's zeros, like zeros with negatives. So I think just making sure that when you read through it and implement it, you're able to capture all the edge cases. And I
Yeah.
think just working on getting it running up and running fast and with no bugs.
Yeah. I
Because
think like when I
go ahead.
yeah, I think when I solved it, I was just doing it intuitively, and then I kind of didn't think through the edge cases. Like it
Yeah.
wasn't kind of in the back of my mind. I just intuitively figured out that this is what you need to do, and
Boom.
then I
Yeah.
didn't think of the edge cases like that.
That was
Yeah.
good. That was good. I think even if you
Mhm.
didn't, the prompting was fine. I don't think I would dock more. I think the main part where I would dock was just where I would have docked on that question was just getting it up and running and working.
Yeah.
I think there's a few things. It just wasn't working for all the different cases at first, and we had to like run and iterate it. So I
Yeah.
think
And
just working on getting it done fast with
mm,
speed. But I think honestly the question is not that easy. You're able to
mm.
find it. So problem
It was
solving is
like
not your
yeah.
issue. It's more just
I kind of used templates like when I started coding. So it's like does not equal scene dot find. Like scene dot find does not equal that. But
yeah.
I kind of wrote that down like I didn't really think about like what that means. I just kind of wrote that down because it was like something I wrote myself like a lot of times. Usually
Yeah.
it works. Yeah.
Yeah. And then for question 2, I think you
Mhm.
found out how you need to do it. It made sense.
Mhm.
But then you just trip yourself out with well where you got stuck is where candidates always get stuck when asked this is they realize they need to do a BFS, but then they
Mhm.
realize that they're given a tree, so it's not in a structure where they can perform a BFS.
Yeah.
So I think yeah, I mean now you've seen it. I don't think
Yeah.
you'll fail that question, but
Mhm.
with a lot of different questions, sometimes you'll see it and sometimes transform or building an intermediate data structure like an
Mhm.
adjacency list or transforming it slightly like pre-processing it will help you solve the algorithm. So I would just look into that when
Mhm.
solving other questions. But yeah, I want to ask you this question because it's a
Yeah.
useful
I think
question.
yeah. I don't know. For this one I got stumped because I was thinking mostly in the tree. I had like this side thought for a second, but I didn't really push into it. I was
Yeah,
like, what if we convert it to an array? But then I didn't really say that.
yeah.
Yeah.
So I think yeah, I think your
Mhm.
honestly your problem solving skills are fast, but I would just improve the pace a bit in order
Mhm.
to just shine more in the interview because
Yeah. I
a
think
lot
like
of
when I
it's
start
yeah,
coding it out, it's like mostly intuitive. And then once I trip up, I have to rethink through my whole
yeah.
entire code. And
Yeah.
yeah,
How many questions did you solve?
like 81, I
Yeah,
think.
see you're still haven't solved that many
Mhm.
questions and so you're pretty talented. I would say once you get to
Mhm.
like 150, 200, you're going to be
Okay.
just going crazy. So, yeah, good job. Thanks
Yeah.
for coming out and doing the interview.
Yeah. Thank you
Appreciate
for
it.
hosting this. It just
No
kind of makes me
problem.
realize where I'm wrong. Yeah.
Yeah, yeah. Happy that it helped.
Thank you.
Let me like feel free. When do you need to be ready by? Summer 2026 you said?
Yeah, that's when, well, new grads applications start opening up this
Yeah.
fall. So
Yeah, I
if
mean,
I
keep
pass the
practicing
residency, yeah.
and feel free to book. I'll be posting more like
Yeah.
links later. So whenever you want to do another one, you can find another
Hmm.
slot.
Right. Thank you.
Cool. All right, man. All right. Have a good night.
You too.
See ya. Peace. Cyclops, how do you know about that DoorDash question? I literally got folded by that question by DoorDash. It was so bad. I do not want to be. Oh, did I? I swear I asked you that question, I think. All right. Yeah, I remember. I remember that now. Holy, I've ran so many of these, I forget, but I definitely remember that interview. But yo, I'm back, and we're gonna be helping people get ready for coding interviews. Thanks for tuning in. Catch y'all in the next stream. Tomorrow I got more streams. Probably gonna chill out and sleep tonight. Look for some food, but thanks for coming in. I got work tomorrow, so I gotta sleep. It's only 10 p.m. But yeah, catch y'all. Good night. Good night. Yo, Shars, appreciate you.